What's up, everyone? Today we're going to be starting Unit 4, and in the first section of this unit, we're looking at different operations to perform on functions, okay? In this video, we're going to look at the operations of addition, subtraction, multiplication, and division, okay? So suppose we have two functions, f and g of x, okay? If you see this notation, f plus g of x, that's just a slightly shorthand notation that's telling us to take the function f of x and add it with the function g of x, which is really nothing more than combining the like terms between the two functions, okay? Similarly, f minus g of x would be saying to take the function f of x and subtract it by g of x. F times g of x is really just asking for the product of f of x and g of x. You'd be using the distributive property. And then f over g of x, or f divided by g of x, means take f of x and divide it by g of x. Okay. Now, not only do we want to perform these four operations on our functions, we also want to be able to find the domain of the result of each of these operations, okay? So the domain for your sum, your difference, and your product of these two functions is going to be the set of all numbers that are in both the domain of f and the domain of g. So basically, whatever the overlap is between the domains of the two functions, that's going to be the domain of the resulting function, okay? Now, for the quotient, it's going to be the same thing in terms of the domain, except for there's one extra piece you got to look out for. When you're finding a quotient, more than likely you're going to end up with a fraction for your quotient, okay? And what we'd want to do is make sure we exclude values from the domain that would make that fraction have a denominator of 0. Okay, so that's something that we'll have to look out for. All right, so consider these two functions. F of x equals the square root of x, and g of x equals x minus 4. So we have a square root function, and then we have a linear function, okay? We're going to find the four operations between f and g, as well as give the domain for each of these, okay? So I'm actually going to start by just reasoning out the domain for each of these functions, okay? The domain for f is going to have to be any number greater than or equal to 0, okay? Since you can only take square roots of non-negative numbers, okay? The domain for g of x is going to be all real numbers, okay? That's because it's linear, no restrictions on the domain, all right? So we'll just kind of keep those in mind, and now we'll find the operations, the various operations between these. So let's say I want to find the sum f of g of x. That's going to be equal to the square root of x added with x minus 4. And notice I put parentheses around x minus 4 to start here, just to show that that whole expression, that binomial, represents g of x. But really, the parentheses are unimportant here. I can drop those and say that this is my simplified sum. Okay. Now for the difference between f and g, the parentheses matter. So that's going to initially look like the square root of x subtracted by the quantity of x minus 4. Okay, and the parentheses matter because it shows me that I should be distributing this negative. That's going to give me the square root of x minus x plus 4 for my difference. Okay, now I'll find the product. Which would be the square root of x multiplied by x minus 4. This is going to require you to distribute the square root of x, and that's going to give us, I'll write it as x times the square root of x minus 4 times the square root of x. Okay. All right, now the domain for all three of these should be the same. Okay. These are all going to have a domain that is the overlap of the two original functions' domains. Well, that's really simple to find in this case, since the domain of G is all real numbers. The overlap between the two is going to be the domain of F, which is any number greater than or equal to 0. Okay. All right, now what about the quotient? Okay. We'll write that like this, F over G of X. All right, and that's simply going to be equal to the square root of X over x minus 4. Okay. Now, domain for this is going to include any number greater than or equal to 0, but we also have to consider, is there any number that makes the denominator of this quotient turn out to be 0? And in this case, it would be x cannot equal 4. Okay. So you can write it like that, or here I think is a really appropriate time for interval notation. You could say your domain is 0 to 4, where 0 is included, 4 is not, and then union 4 to infinity. Okay.